I see that people are coming into the main room now. So let's make a start. So good afternoon or good morning to you, depending where you're joining us from today. So a very warm welcome to this Picterra Q1 roadmap update. Now this webinar is the latest in a series of events that we've really put together to showcase some of the great new features that we've recently launched, or indeed will be launching within the Picterra platform. Now, if you're an existing customer, an especially warm welcome to you. Thank you for joining. I do see some familiar names popping up in the attendee list. Hopefully this session will give you some insights into some features that perhaps you haven't had the chance to play with yet. Now, prospective customers, those just curious to see what platform is capable of, we're also very pleased that you've taken the time out to listen to both myself and Julian today. Now, we're going to be focusing on two very exciting new additions to the Picterra platform, that of advanced tools and dataset recommendation. We'll also be looking further into the future and giving you a sneak peek of what's to come this year, so stay tuned. Now, a quick intro before we begin properly. So my name's Dan. I'm the content marketing manager here at Picterra. So if you've already visited our blog, if you've downloaded a white paper, or indeed liked any of our social posts, a big thank you from me personally. Now, if not, there's always time to get in my good books, so please do check out both picterra.ch/blog and picterra.ch/resources for a wealth of material related to geospatial machine learning, but please after the webinar. Now, I'm also very pleased to be joined today by our Chief Technology Officer, Julian, who I'll now introduce himself.
Hi, nice to meet you. Happy to be here. Thanks, Dan, for the introduction. So I'm Julien. I'm the CTO at Picterra, and so I'm managing the development and the research and development we do on the platform. And I'm excited to present you two of the newest features that the team has been working on in the past few months.
Great, thank you, Julien. Now, here's our agenda for today. So following this brief welcome and introduction, Julian's going to take over and dive straight into advanced tools. Now, this is a feature we introduced just last month, and I've already had some very positive feedback about. Following a short demo of them in action, he'll move on to introducing dataset recommendation. Now, for those familiar with Picterra, you may recall the launch of dataset exploration last year. And indeed, this is the next stage in the evolution of advanced data curation functionality within the platform. Towards the end of the webinar, we'll take that look into what's coming next before wrapping up with a Q&A session. So during today's presentation, please do send your questions that you may have to the chat panel, which if you click on the toolbar at the bottom of your screen should show on the right-hand side. Please do select Picterra host or Picterra team as to send the questions to, and you can send in any questions that you may have. So not just related to new features being discussed today, but anything you have about the Picterra platform itself. Now, Julian does like to be challenged, so please make them as tricky as you can. And to answer a frequently asked question, yes, you will be receiving this recording along with the slides that we are presenting following the webinar. So with that, thanks again so much for joining. I'm going to hand over to Julian to take you through advanced tools and dataset recommendation. I'll be back at the end for the Q&A session. Thanks, Julian.
Thanks, Dan. Thanks for the introduction. So before we dive into the new features, just wanted to explain quickly where Picterra stands in a typical geospatial imagery analysis workflow, mostly for the prospective customers among you. So at Picterra, we provide a geospatial MLOps platform, and where we stand really is between the imagery. So on one hand, you can ingest a variety of imagery on the platform, so optical imagery, infrared, radar imagery, DSM, and so on, and also connect to different type of imagery service that are common in the geospatial world. And then there is really what we provide on the platform, and then you can use the tools on the platform and then export your results either through some other GIS tools that you have in your workflow, or you can also automate things through the API. So now if you look a bit at what's inside the platform, there are 4 main blocks. The first one is obviously machine learning model trainings. We have a full user interface to annotate and train your model and do some tuning of the settings and so on. So today we'll introduce a new dataset recommendation tool, as Dan mentioned, and this is part of the data creation and model analysis feature group that we have around our machine learning models. Then there is obviously data management and results management. So today we are not introducing anything new here, but you can obviously use Picterra to manage your geospatial imagery data and your results. And then the second thing we are introducing today is what we call advanced tools. And it's a new kind of feature group within the platform that simplify some common pre-processing and post-processing tasks that you usually want to do around the geospatial machine learning model. And then obviously all of this is running on our cloud infrastructure, so you get some pretty nice scaling for free and the usual robust platform that we provide to our customers. So with that being said, let's dive into the first feature that we are introducing, which we call advanced tools. And the general idea behind this is really a way to streamline and simplify your geospatial workflow by simplifying some GIS operation directly within Picterra. So the reason we are introducing those tools is that we have a lot of customers that are doing some typical operation that you do on geospatial imagery, and this operation also, they are typical. They can be pretty let's say require multiple steps to do in a typical GIS software, and what we want to do on the platform on Picterra is allow you to do those in a few steps as possible, and basically make your whole workflow more efficient. So we are starting with 3 tools, and we'll go a bit more in depth afterwards into what each tool is doing. One of them is an NDVI tool, or more generally an index computation tool, because you can also compute water index and other indices similar to NDVI. So if you have an RGB image with the infrared information, you can use the tool to compute an NDVI index, and then use that to train a custom detector and do some typically vegetation mapping use case. The second tool we are introducing is what we call DSM height extraction. This one is slightly more complicated. The general idea is, let's say you're doing some construction monitoring, so some building construction monitoring, and you want to monitor the height of your building as it's getting built. One way to do this on Picterra is that you will detect the building footprint, but then for the footprint, let's assume you have a DSM coming from your drone flight with some height information. You would like that for each building, there is a property attached to the footprint telling you the height of the building. And then you can use this property to do further analysis on, okay, is the construction on track or not? And so the DSM height extraction is doing exactly this. So you can take a set of detection, let's say footprints from a building, and then if you have the height information, such as a DSM, then you can attach the height to each detected building or polygon. And the last tool we are introducing is image stacking. So this is a tool that typically allow you to stack images coming from different sensors. And a typical use case is, again, if you have optical data and then you also have DSM data or infrared data, and they come in different files or from different sensors, you can use the image stacking to stack all of this into a multispectral image. And then what's cool is you can use this image to train a detector. And it means the detector, so the machine learning model, will leverage all of the information you have within your image. So it will leverage the optical data, but also the height information, like the infrared information, whatever you have as a modality. And this can lead obviously to much more robust and much more accurate detector, because you have just more information to work with. So in a bit more detail, let's start with image stacking. So an example case here is you have an optical image. So you have 3 bands: red band, green band, blue band, that you typically get from, let's say you fly a drone over a region, or you have a satellite image of a region. And then let's say you have some kind of elevation model. So it can be a DEM, it can be a DSM, it depends a bit on the use case. But you have a single band image that's giving you some height information. And what you can do with the image stacking is you can take the two images that you have and then create a 4-band composite image, and we automatically resample the image so that they match on a spatial resolution. So we take all of the, let's say, complexity away from this, and we make it really simple, as you will see in the demo in a few seconds. The second tool is NDVI. So NDVI, typically you compute it from the red information, so the red optical band and some near infrared band that you acquire on the same drone flight or from a satellite. And what we do here is really a tool where you can select the two bands, and we will compute an NDVI image that you can use directly to train your vegetation detector. Again, this one it's something you can do in some drone software. You can also do it in some GIS software, but by doing it on Picterra, it just streamlined the whole workflow. The last tool we are introducing is DSM height extraction. So as I explained before, you have some buildings detection because you're doing some construction monitoring project, for example. And what you will do is you will use the height information that you have in your DSM or DM, and based on the detection, we'll select the average and the minimal and maximum height within the footprint of each building. And so, therefore, at the end, what you get is the footprint of each building, but you also get as an attribute on the polygon the height of the building, and then you can use this in whatever GIS or construction monitoring software you're using down the road. And this is not only limited to construction, but another typical use case for this is if you're doing some forestry or some, let's say, agriculture use case, you can use the height of plants to assess the growth and the yield and different things, things like that. So you can really get creative and kind of use the tool for whatever use case you have. So let's look at two demos of how you can use the advanced tools and what they actually look like on the platform. So we'll start with the NDVI tool. So the way you access it is you have an advanced tool button when you're within the platform in a project, and then you can select from here which tool you want to run. So in this case, we want to run the NDVI tool. And the way to use it is that you have to select your input image, and then you have to select which band is the red band, which band is the infrared band, and then you have to select a folder to output the NDVI image into, and then you get the NDVI image in a typical green color map that you have here, and so light green is low NDVI, dark green is high NDVI. And then you can use this image obviously to train a detector. It's interesting to mention that you can also use this image to stack it with another image. So you could stack the NDVI image with the DSM image using the image stacking tool. So you can also combine the tool and kind of build your own workflow for your specific case, depending on what data you have available. Let me move to the next. Okay. The second demo we have is DSM height extraction. So as I explained before, for this you need different type of inputs. So on one hand, you need some detection or some polygons that will be the footprint within which we extract the height. And obviously you need also an image with height information. So typically a DSM, and it will output a new set of polygon, a new result with the height attached as a property to each polygon. And so you can see here, those are the detections. So this is like the inputs we gave to the tool, and then this is what it looks like if you visualize the property of the polygon in a GIS software. So in this case, we are using QGIS, and you can see that each polygon is coming with some number attached, which is the height. In this case, I think it's in centimeters of each plant or of each tree in your plantation. And so this is this is a pretty cool tool, because this is an operation you can do in a GIS software, but we really automate most of it. And whereas it can take I don't know, 10 to 20 clicks and some settings fiddling to do in QGIS or ArcGIS, you can do it very, very quickly and efficiently within Picterra. So to summarize a bit the idea behind advanced tools and why we are introducing them, so there are multiple, let's say, challenge they allow you to overcome. The first one is we want to streamline and simplify your workflow and basically avoid having you jump back and forth between Picterra and some GIS software and then back into Picterra and so on, because this type of back and forth is hard to document within your team. It's also time consuming, and at the end of the day, it's not efficient. The second reason advanced tools are very interesting, and this is mostly for the NDVI and the image stacking tool, is they allow you to build basically better models, because you can use all of the information you have within your imagery to train a machine learning model. And so you're not only limited to choose between optical and DSM to train your model, but you can stack all of this information and have the model leverage all of it. And the last thing is reducing complexity. So if you're working within a team environment and you need to document your workflow, by having all the tools within Picterra, you can have a more uniform and a simpler documentation and general workflow. So you also minimize the risk of errors or the time lost jumping between tools. I also want to say, before I move on to dataset recommendation, that we are just getting started with tools and we have some ideas to add new ones. But obviously, we would also be very interested in learning about what you would like and what problem you're facing that you feel are inefficient and could be covered by a Picterra tool. So if you have this kind of feedback, we are always super happy to discuss it and learn from it. The second feature we are introducing today is what we call dataset recommendation. As Dan mentioned in the introduction, this is the natural evolution of the dataset exploration feature that we introduced at the end of the summer of last year. And it falls under the general idea, and this is a long-term thing that we are pursuing at Picterra. It's the general idea to boost the accuracy of your model and to allow you to build better model, and also to give you the tools to do some data creation and in a visual way, so that you can also get insights and some intuition about your data set and what are maybe the regions that are challenging and so on. So dataset recommendation right now, and we will jump in a demo in a minute. It's part of what was called the dataset exploration feature when you're training a detector. And it allows you to do multiple things. So one of the first thing it allows to do is that it will help you automatically identify parts of the dataset that are underrepresented. And typically this means you might have a data set where you are detecting an object of interest. Let's say you're detecting cars, and you have different type of backgrounds. So sometimes they are on a concrete parking or on concrete road, and sometimes they can be on a dirt road, on snow, and so on. And obviously, if you want your model to be robust, you want to cover this variety in the background and in the context in your training set. And so dataset recommendation, what it does is it allows you to automatically suggest you in your training set region that you should annotate, so you're more efficient when you're doing the annotation process. The second one is it avoid doing redundant training areas, and this is a bit linked to the first one, but by recommending to you where to annotate, it avoids annotating over and over again the same context, which at some point it's not bringing much to the model. If most of the annotation are the same, the model is not learning much. It's much more efficient to give variety of annotation and variety of context to the model. So again, this is a way to maximize the impact of the annotation work that you're doing and to make sure that you're not wasting your time re-annotating similar region. At the end of the day, this is all about reducing false positive by adding more training area and making sure that the model is really covering seen the variety in your data set. And it's also helping you understand and interpret better what the model is doing, how your data set is looking, what are the different challenging areas within it. And so it's also part of a trend of explainable AI and trying to open the black box of the deep learning model. So let's jump in the platform to see what it looks like in practice. So this is an example detector. This is a detector where we are detecting tree holes. So the use case is that this is part of a tree planting project, and they have to dig holes to plant new trees. And the first thing they want to do is they want to map the holes to have an up-to-date list of places where they should plant tree. And then in a second step, what they want to do is monitor the growth of trees. So they want to check after a few months if a tree has really grown where it was planted. And so this is a detector with a few, 35 training areas. So it's a reasonably, let's say, medium-sized detector. You can see that if I go a bit through it, you can see that it's already covering a variety of context and background. So I would say it's not too bad, and it's so quite some work has gone in that detector already. But you can see that the accuracy is not that great yet. And so what we can do is we can go in the dataset recommendation report tool here and generate a dataset recommendation report on this detector to see what the system is telling us we should focus on. And this is the type of result you will get if you generate a dataset recommendation report. And I think let me first start by breaking down a bit what we are seeing here on the screen, and then we'll see exactly how we can use the recommendation. So the first part you have in this report is the visualization here. That is not a geographic visualization. So this is not about showing geographic location, but it's about showing the diversity in your data. And the way it works is you see that we have small square of images. So these are small. We break down the images into small patches or small rectangles that you can see here. And then what we do is we use a technique called unsupervised learning. So it's one area of machine learning and of deep learning, where you can have a system learn from the data without having access to labels, and it will cluster the different rectangles we have by similar content. And so if I zoom in here, for example, you can see that I have a cluster at the bottom here, where it's mostly about rectangles that have some snow. And this is a data set where one of the image happens to have snow, and we have a bit of a snowy cluster here. If I navigate a bit, you can also see that I have, for example, here I have a cluster with typical tree plantation holes pattern. Here I have a cluster that looks a bit more like bare soil or a farm field. I'm not exactly sure what it is, but you can see that visually it's similar. And so this is really the idea that this visualization is showing you the diversity in your data set. And if you look at a cluster of rectangles, they will be visually similar. So then what you can do is you can first show the coverage of your training data on your dataset. So here I just enabled the show training area coverage, and you can see that I have a yellow, some yellow circles here appearing that are highlighting the region that are covered by my training data. And this is already very interesting because you can see that the whole bottom here that was including the snowy region is not covered by my training area. And this can obviously be a problem because if I train the detector like this and I run it on an image with snow, it might fail to detect and I will get bad results. And then maybe more importantly, or at least equally importantly, it's also showing you the coverage of the accuracy area. And this is quite a key thing to understand, is that you want your accuracy area. So this is the area where we evaluate the detector and we give it an accuracy score. And you saw I was at 70% accuracy in this one. You want this area to really cover also the variety in your dataset. Because if you don't, it means you're evaluating the detector on a test that's too easy, let's say. So if you're just covering a very specific part of your data set, it will not, the score that you will get, so the accuracy score you will get is not representative of the performance of the detector when you run it in production. So it's really key that both the training area and the accuracy area are covering really the whole span of your data set. And this is exactly what dataset recommendation is doing. So if I navigate a bit in my image here, so I can see the image that I have in my dataset at the bottom, and the color are showing the different groups. So it's a way to visualize how visually similar different regions of the image are. And this is the image where I have some snow. So you can see that if I zoom, there is some snow here. In this region of the image. And I have one thing here, which is a dataset recommendation marker. And so this is the way the system is telling me that I should add a training area in that region because it's not covered by the dataset. And it makes sense, right? Because we've seen before that the snowy region was at the bottom here, and as you can see in this visualization, it's not covered by the yellow region. So this is pretty key that I make sure I introduce at least some training and accuracy area in the snowy region, so my detector is robust to snow. And likewise, you can see if I move to this image here, that this is covering the region, so the green region I had here at the top, which looks like some bare soil. And again, this was not included in my training area, and so it makes sense to add a training area here. So the detector has also a counter example to learn from, and it can learn that it shouldn't detect tree holes in this area. So typically, what you would do after generating this report is you can go back here to the training user interface within Picterra, and here I can navigate through the recommendation that I got from the system, and let me use this image here with the snow as an example. So you can see that I have a bunch of recommendations that were generated on this image, and typically the action I would take is I would add a training area here around this marker, and then make sure that I annotate every object of interest that is appearing in this training area. In this particular training area, you can see that there is no tree holes, so I'm not going to annotate anything, and so it's going to be used as a background training area, and then I could resolve the marker. And then likewise for the other one that was recommended, so on this image, here you can see that it's recommending me to annotate in the region that includes some of my object of interest. So what I will do is I will add the training area here, and then I will make sure that I annotate all of the tree plantation holes that are appearing in this training area. And again, this is really key that you annotate all of the object of interest falling within training area, because otherwise the model is not able to learn from your data properly. So this is typically how you do one iteration of dataset recommendation. What I would do next is I would train the detector again, and I would check if the accuracy score is increasing, and I might regenerate another dataset recommendation report to recommend me new regions or new areas to annotate. And I think it's important to mention that on every time you generate a dataset recommendation report, you will get 10 new suggestions. And so you can do this a number of times to improve your detector and be a bit more guided into how you're doing this on the platform. So on this particular example, we actually use the dataset recommendation to improve this detector, and so we can do a before-after comparison. So this is a dataset in which we had 64 training areas originally, and then we did 2 iterations of dataset recommendation, and therefore we added 20 new training areas in the different regions that are recommended, and we saw a 10% accuracy improvement. So it's pretty good improvement, and I think it was much quicker to do with dataset recommendation, because you don't have to manually navigate through your dataset and kind of think, okay, should I add an area here, or here? You can just follow the markers and add training data where the system is recommending you to do it. And you can see here some visual before after, so you can see that we greatly reduced the number of false positive in the snowy region and in this type of background. You can see that it's not perfect yet, so typically you would do still more iteration to make it perfect. And you can also see that we also were able to reduce the false negative problem. So here this one was missing, and you can see that in the after case it's now detected properly. So yeah, I think it really showcased that you can use this as a way to guide you when you're building your detector and remove some of the, or let's say simplify the decision process on where to annotate it. So to summarize dataset exploration and dataset recommendation tools, again, the general idea is to help you and to support you into building better detectors. So we want obviously our users to have the best model possible. And the way to do this is first by quickly assessing the training area and the accuracy area coverage on your dataset. And this is the visualization that we saw with the blue and yellow highlight. It can also allow you to automatically identify unrepresented parts of the dataset. And typically this was the case with the snow background, where we were completely missing training data on this type of context or this type of background. Overall, at the end of the day, it's all about improving dataset quality because we are making sure that again, your dataset is covering the variety that you have in your imagery. And then very important, as I mentioned already before, it's also making sure that your accuracy area, so your validation or accuracy set, is also covering the variety in the dataset. Because if you don't do this, you may get a really good score when you train your detector, but then you will get some surprises when you run it in production. So it's always key to make sure that the validation accuracy set is representative of your dataset and the type of image you will get when you run your detector in production. So that was it on the two new features that we introduced recently. I wanted to give also a bit of a sneak peek at what's coming next and what are we working on currently. And obviously there is more than two features, but let me highlight those two. The first one is production drift monitoring, and this is interesting because it's the same underlying technology that we use for dataset recommendation. What it will allow us to do is when you run a detector on a new image, we will be able to warn you if the image is too different from the training data. And typically this is very key, because if, let's say, you have trained your detector on imagery that was acquired from a specific sensor from a specific altitude, and then you run it on imagery from a new sensor, different illumination condition and things like this, the detector might not be robust enough, and it might fail to produce good results. And so with production drift monitoring, we are able to monitor this kind of shift between the training dataset and the production dataset, and warn you as a user and tell you, maybe you should have a look at this image because it seems too different from the training set. And from there, either you add it to the training set and you make sure that the detector is robust, or maybe you just do a bit more quality control after the fact, and make sure that you check the region of the image that are very different from the training set. The second feature we are working on, and it's a completely different feature area, is compatibility with ArcGIS imagery server. So as some of you may already know, we invested quite a bit into making an ArcGIS plugin, because a lot of our users are using the S3, the various S3 products, and they are deeply involved in the S3 ecosystem. And so we have an ArcGIS plugin that you can use to automate some of the tasks that you do on the platform and to get your results directly in ArcGIS. But what we want to do with ArcGIS imagery server is allow you to directly connect your imagery that is stored on ArcGIS imagery server to Picterra. And so again, this is a way to streamline your workflow, because currently you have to download the image from ArcGIS imagery server and re-upload it on Picterra, and this is time consuming, error prone, and so on. And so with this feature, you will be able to directly point Picterra to your ArcGIS imagery server or your ArcGIS online, imagery server, and then use all of your imagery that's already there, and we automatically fetch it when needed. So yeah, that was it for the new features that we introduced recently. I will let Dan see if we have any questions and try to answer them as best as I can.
Yep, thanks, Julian. Great stuff. So we've had a few questions come through on the chat. So thank you to those who have sent them through so far. There's still time to get them in, so please do remember to put them into the chat panel. If we don't have time or we haven't got around to your question, we will follow up after the webinar today. So please just make sure that your name in the participants view matches the name you use when registering, so we can follow up with you personally. So the first question we have for you, Julian, I think this may have been answered a little bit already in your presentation, but how much improvement in a accuracy score can I expect to see if I use the dataset recommendation tool?
Yeah, this is it's a good question. It's also a bit of a tricky one to answer in a general case, because it will depend on the use case. It will also depend on the stage your model is in. So as you've seen on the tree holes example, we get a 10% accuracy improvement on this model, but I think you will get the most if you use it at the beginning, because you have less training data, and then at the end, it might allow you to bridge the gap from, let's say, 92% accuracy to 94% or 96 to 98. So, and usually the gain you get at the end are much harder to get and much more time consuming. But so dataset recommendation is also a way to make sure that at least you focus the annotation effort on what's the most impactful and to get you to a better accuracy quicker.
Got it. Thank you. And moving on to advanced tools, we've got one from Guillermo who's asked, regards image stacking. So is it possible to combine images that initially have different spatial resolutions? Does the tool resample the rasters to the same resolution?
Yes. Yeah, that's a good question. The short answer is yes. One thing I'm not sure right now from the top of my head is whether we resample to the highest or lowest resolution between the two rasters, but we definitely do some automatic resampling. I think this should be documented in our documentation, or maybe we can follow up. But yeah, you can definitely have image with different spatial resolution. Obviously, you may not want to do this if the spatial resolution are completely different. So like stacking a 10 meter image with a 5 centimeter image might not make a whole lot of sense. But if the resolution are close, we do some automatic resampling and simplify this step as well.
Great. And as a follow-up question from Guillermo as well, which maybe we need to follow up afterwards, it's asking the maximum number of bands that can be combined with the image stacking tool.
I don't think we have a limit. So, I mean, I haven't tested with 400 bands, but yeah, I think we've tested with 50 bands raster. So you can go pretty creative there, I think.
I would say give it a go. See how high, sky's the limit.
And let us know if it doesn't work.
Yeah. Another question on the advanced tools that we had come through is, can you create a customized advanced tool for a specific use?
That's a good question. So the answer depends, but it's something we are exploring with some enterprise customers that might have some very specific requirements and some very specific post-processing steps. And in this case, we do have the technical capability to create some custom advanced tools. So yeah, it's something we can discuss with enterprise customers.
Great. And one on the upcoming ArcGIS image server functionality, will it support ArcGIS image for ArcGIS Online?
That's a good question. I think so, but I would need to double check this with the team. So maybe it's something we can come back to that particular person, because I know that it's not exactly the same thing as on-premise ArcGIS imagery server. I think our ultimate goal is yes, we should be able to, like, we want to be compatible with the most of the S3 imagery hosting options. It might maybe not be available in the first version that we release. So it's something it's more of a timeline question, I think, than than anything else.
Okay, perfect, thank you. So back on dataset recommendations, someone's got a question: how many iterations of the report should I, in general, consider? What does it depend on?
So I think it depends on your target accuracy. So usually when you have a use case, you should know, or you can define, okay, for this use case I need 85, 90, 95% accuracy, depending on the business case behind it. And so the way I would actually recommend working is that you start by defining accuracy areas that are really covering the variety in your dataset. And then you take it as a challenge to get whatever accuracy you're aiming for on these accuracy areas. And you do iteration until you reach the accuracy that you need, depending on your case. So the answer is, it depends, but I think the general flow of starting by defining accuracy areas and then trying to reach whatever target you have is the right way to go about it.
Okay, perfect. And I think we've got one final question from Catherine. Can you use image stacking tool for change detection?
Yes. So yeah, that's actually a good idea and an original idea to use the tool. So you can do this, and the way you would do this is you would stack the before image and the after image. So let's say you have optical imagery before and after. You stack 2-3 bands image, and you get a 6-band image, with the 3 first band being the before data, the 3 last band being the after data. And then you can use our band spec tool to visualize and annotate the change in this image. And the detector will use the 6 bands, so it will figure out that you're actually interested in change. On change detection, it's also something that we are thinking about on our roadmap. So, and we might introduce in the future some tool to visually simplify this type of change detection workflow.
Great stuff. Okay, well, I think that comes to the end of the questions. I can't see any more in the chat.
I do have 2 actually that were sent directly to me. So if you have
Okay.
a bit more time, I can quickly go through them. So there is one which is about what is the accuracy when adding height? What is the minimum requirement of a DTM? So I'm not 100% sure I understand this correctly, but if I understand it correctly, we don't really have a minimum number here. So your DSM, typically it might come as a float image, floating point image, and we'll keep that information. So I think the answer is the image stacking or the height extraction tool are not limiting you into what you need to input, and it will use whatever you provide it. So yeah, it really depends on where the data is coming from and the quality of the data. And the second one is around the advanced tools. Will the advanced tools become accessible through the API? Yeah, that's a good question. Yeah, definitely. So it's something we want to do at some point. I think it's not clear yet where it is on the roadmap, but I think if you're interested by this and you have a good case for it, please reach out, and we are happy to always prioritize things to serve our users.
Okay, well, we just had a final question that's just been sneaked in by Sarah. So she's asking if there's any work being done on the object editing tools. And a suggestion from her would be nice to be able to undo the last vertex while creating outlines for complex polygons.
Yeah, that's a good point. So this is on our roadmap. I would say first, like Q1, Q2 this year. It will depend a bit, but yeah, it's definitely something we want to do, improving the annotation tool that we have. So there is definitely some things when you edit complex shape. We also wanted to look into things like a magic wand tool like you have in Photoshop or some image editing software. So we have a bunch of ideas there, but always happy to hear more feedback from users on this.
We've had one more, but I think it might be a quick answer. So is there an additional cost for advanced tools?
No. That was a quick answer.
Yeah,
no,
certainly was.
They are free to run.
And a good answer to hear. Great. Well, I don't think there's any more questions. So all that remains is to say a big thank you to Julien for presenting and taking us through these new features. Also, a big thank you to everyone who joined and participated and asked questions during today's session. As I mentioned at the start of the call, the recording and the slides will be sent in a follow-up email. You're receiving that in your boxes tomorrow morning. And if you do want to find out more, we have our website, picterra.ch, along with all of our social channels as well. If you want to follow up with any of us, do so by replying back to the email that we send out tomorrow morning. But otherwise, thanks again, everyone, and have a great rest of your day.
Thanks, Dan, for hosting, and thanks everyone for listening.